Hi, this is a demonstration video for our project, which is MD-SAL based firewall for software-defined networks. The motivation behind this project is that in traditional networks, the network operators need to configure each individual device separately using either vendor-specific or low-level commands. Also, traditional networks pose a number of challenges such as performance, cost, flexibility to access control, management, and policy establishment. The reason behind this is that the traditional network lack global view of the network topology, due to which the operators find it difficult to enforce the required policies in a continually changing environment in an autonomous manner. In order to address these shortcomings of the traditional network, SDN framework provides a centralized platform which gives granular control over the ways switches can handle packets, and it also gives an ability to automatically prioritize and block certain types of packets. So our approach is to demonstrate the basic firewall functionalities that SDN provides by making use of Open Daylight framework for the controller. Coming to the security threat model, we are considering the insider threat, wherein the attacker resides inside the network. So this host is our attacker and this host is our victim. So when a malicious flow is sent from the attacker to the switch forwards the first packet to the controller, which in turn sends it to the firewall. And if there is a match and action for a pattern which is suspicious, then the firewall informs the controller about this, and then the controller installs a flow rule to drop the malicious packet. So henceforth, the packets which come from the attacker, which belong to the same flow, will be dropped. So this is how our security threat model looks like. The experimental setup consists of three switches, which is logically connected to the controller. The controller makes use of Open Daylight framework. We have host H1 connected to switch 1 and host 2 connected to switch 2 and host 3 connected to switch 3. The firewall module is hosted on Glassfish server, the code for which is written in Java. For our project simulation, we make use of Ubuntu 14.04 virtual machine. The code of ODL has already been downloaded, and it is of Lithium version. So to run and start the Open Daylight controller, we make use of this command. So now the Open Daylight controller is up and running. The next step would be to install the required features such as best config, MD-SAL, and L2 learning switch. So the command for that is as shown. Once all the features are installed, check whether the L2 switch module has been initialized. This brings up the controller and the L2 switch module. Once the controller is up and running, the network topology needs to be simulated on Mininet. The command for which is as shown. So this adds the controller and adds the host and the switches. Now let's do ping poll to check the connectivity and reachability with all the hosts. So the ping was successful with 0% dropped packets and all packets were received. This is our code for the firewall module. Once we build and run the project, the web page pops up, and this is how the web page looks like, wherein we have three options. One is to view the existing flows on the switches. The next one is to insert the firewall rule, and then the third would be the topology and connection information. Now let's have a look at the topology and connection information. So the node information is given by these, and the connection looks as follows. Now we can also view the existing flows on the switches by going to this and then we enter the ODL IP address and then the port number and the switch ID. So in this case, let's enter the first switch. And initially, these are the rules which are in the switch S1. So in order to insert a firewall rule for universal blacklist, let's go into the insert firewall rule option. So the page looks as follows. We enter all the mandatory field values like the switch ID, ODL, IP address, ODL port, and we drop, the action is set to drop, and provide the flow name, the priority, and the flow ID, and we hit on submit, which takes us to the preview window. And then when we format to check the XML, it looks something like this. Now we push the flow. So if the push has been successful, then we get the response code as 200. Now, in order to check if the flow has been, if the flow entry or the firewall rule has been successfully inserted, we go in and check in the view flow entry table. So we can see that our flow, which had flow ID of 6 and a priority of 600, has been added. In order to check that our firewall rule is successfully inserted, we try to ping H2 from H1. So it's unreachable. But when we try to ping H3 from H2, it is pinging. And so the demonstration of universal blacklist is successful. So in a similar fashion, we can block based on TCP or UDP protocols by adding different rules based on match and action criteria. With this, we complete our demonstration of the firewall module on an SDN based environment. So we would like to thank Dr. Huang, Sandeep, and Ankur for guiding us through the project. Thank you.